Okay, this is going to be the last part that we do for this lesson of 1-2 power rules. We're going to take a look at a power to a power, which simply means that we have this power, so we have xm raised to the power of n. So when you have a power raised to a power, you simply multiply the exponent. So let's take a look at y. So we have x squared, which is the base of the exponent of 4. So x squared is the base of 4, of the power of 4. So I have 4 x squares. Now, let's evaluate or expand each of these. So we have x squared times x squared times x squared times x squared. So altogether, we have 1, 2, 3, 4, 5, 6, 7, 8 x's being multiplied. So simply, if we would just said 2 times 4, we would get our answer, but this is why it is. This example says we have 3 2 to the 2's. So 2 squared is the base. So we're going to expand the base. So we have 3 of those, and now we expand each of these. 2 times 2 times 2 times 2 times 2 times 2. So altogether, we have 1, 2, 3, 4, 5, 6 2's being multiplied. 2 times 3 gives us the 6. Now let's just apply the power rule. So here we have a power raised to a power. So we multiply it, and we get x to the 0, which we know is 1. Here, the 4 is attached to the x to the negative 2 and to the y to the 3rd. So it kind of acts like distributive property. You are going to multiply this 4 on the outside to every exponent inside the parentheses. So we have x to the negative 8 and y to the power of 12. So we have y to the 12 over x to the 8th. Oops, excuse me, this needs to be x. So erase that, make it neat. It is totally okay if we make mistakes, just let's correct them. Okay, next we have this negative 2. Now, we have 1, 2, 3, 4 factors in this expression. And this negative 3 is going to be multiplied by every exponent to every factor. So that is why I like to write in the understood one so I don't forget anybody. This negative 3 goes to even the coefficients, okay? So we're going to have 2 to the negative 3rd times a to the negative 3rd over 3 to the negative 3rd and b to the negative 6. So now let's go ahead and take care of the negatives. So we're going to flip 2 to the negative 3rd to the bottom. A to the 3rd is coming to the bottom. And then these two guys are both coming to the top. And every exponent is positive. If we want to go ahead and evaluate 3 to the 3rd to get 27. And then 2 to the 3rd is 8. And we're good to go. Okay, you pause the video and try these. And when we come back, we will go over them together. Okay, guys, number 1, we have 2 factors, 2 to the 1 and a to the 2nd, and it's all raised to the power of 3. So we are going to multiply 3 times every exponent. 2 to the 3rd times a to the 6th. This is really 8 to the a if you were asked to evaluate. Here we have 1, 2, 3 factors. So every exponent is getting, again, multiplied by a 3. So we have g to the 12th over 2 to the 6th times f to the negative 9. F to the 9 comes to the top, and then we have g to the 12th. On the bottom, we have 2 to the 6th, which is 64. We can go ahead and evaluate. If you leave it 2 to the 6th, that's totally fine, unless you were told to evaluate, which means you get a value. Simplifying would be totally okay because that's what you're asked to do. Okay, how many factors in this expression? We have 1, 2, 3 factors, 6 to the 1, m to the 1, and n to the negative 3. Each of these factors, we're going to multiply their exponent by negative 2, and we get 6 to the negative 2, m to the negative 2, and n to the positive 6. We're going to simplify our negatives, and 6 squared comes to the denominator, m squared comes to the denominator, and n to the 6 stays the same. If you did evaluate, we're going to get 36 times m to the second in the denominator. This is totally fine.